Okay, we're going to be looking at finding limits as x approaches infinity with some special cases. So just a quick review that if your degree in the numerator is less than the degree in the denominator, your limit will be 0. If the degree of the numerator is bigger than the degree of the denominator, your final answer will either be positive or negative infinity. This is the one that technically your answer does not exist, but we go a step further. And then if the degree of the numerator equals the degree of the denominator, we use the lead coefficients. So the first special case that I want to show you is really just to make sure you're not doing more work than you need to do. So if you notice that there's a really long limit, like examples 1 and 2, there is absolutely no need to combine all of those, getting common denominators, all that mess, no need. You are allowed to take the limits separately and then add their limits at the end for a final limit. So basically, we can treat these as separate limits and then add them together, since that's what the operations are. So for the very first piece, we have the same degree top and bottom, so we can use the coefficients. So that's 9/3. And then the second one, we also have the same coefficient degree top and bottom, so we can use the coefficients. And it looks like we have the same situation for the third piece. So this is 3 plus 5 plus 4, which is 12. So nice and simple there. Number 2, let's just do this one quick. So for the first piece, we have the same coefficients. So this is 1/2. For the second piece, the highest degree is in the denominator. So this is 0. And then I have subtraction, and I have the same degree for this last piece, so that's 3/4. So this is really 1/2 minus 3/4, which is -1/4. All right, and then the next special case we're going to look at is dealing with square roots or some sort of even radical, so 2, 4, 6, etc. So we are only concerned with the leading terms. So that's going to make this a little bit easier to deal with. So our leading term in the numerator is a square root of 144x squared. And then our leading term on the bottom is just a 3x. Now, dealing with the numerator, square root of 144x squared, remember, it's not 12x, it's absolute value of 12x. And then your denominator, we have the 3x. So we can think of that direct substitution, even though it's kind of weird to think about it with infinity, it's still going to work for us. So if I substitute positive infinity, I'm going to have the absolute value of 12 times infinity over 3 times infinity. Well, the numerator is an absolute value, so we know that that's always going to come out positive. So we have 12 infinity. The bottom is a 3 infinity. Those infinities cancel. 12/3 is 4. So your limit of that function as x goes to infinity is 4. And as you look on the graph, as our x values get bigger and bigger and bigger, it's very clear that we are approaching 4. And then the second example here is the exact same function, but we're approaching negative infinity. So this is going to look very similar. So we have that absolute value of 12x over 3x, but this time we're substituting with negative infinity. So we have 12 times negative infinity in the absolute value over 3 times negative infinity. Well, the numerator, it's still in the absolute value, so we know that's going to come out positive. Now the denominator, this is going to be a -3 infinity. Those infinities cancel. 12 over -3 is -4. And as you look at the graph, as we approach the left and our numbers for our x get really small, you can see that our function is approaching -4. Okay, now what do we do if it's a cubed root or an odd numbered radical? So 3, 5, 7, etc. So with this one, we don't have to worry about the absolute value because this isn't a square root, this is a cubed root. So we still only are concerned about our leading coefficients. So here's your leading coefficient in the numerator and denominator. So we have the cubed root of 1000x cubed over 2x. So numerator, cubed root of 1000 is 10. The cubed root of x cubed is x. No absolute values here because this isn't a square root, this is a cubed root. And then your denominator is just the 2x. You can use the coefficient test here. You have the same degree top and bottom. If we substituted positive infinity, we'd have 10 times infinity over 2 times infinity. Those infinities would cancel. 10 over 2 is 5. And when we look at the graph, as our x values get bigger and bigger and bigger, going to the right, you can tell that our graph is approaching 5. Now, what if we were going to negative infinity? So we still have those same leading coefficients. The problem didn't change. So we have our 10x over 2x when we simplify, but now we're plugging in negative infinity. So we have a negative value on top and a negative value on the bottom. So we're still going to have a positive 5. If we have negative 10 over negative 2, still 5. And as we go to the left forever and ever and our x values get really small, we can tell that we're still approaching 5.